Alright, so this is the second video of 2.4A, I guess. So if you haven't watched the first, watch the first. But here we're going to start with example 2. Okay, this is where we left off with the last one. Okay, so it says a meteorologist creates a parabola to predict the temperature tomorrow, where X is the number of hours after midnight and Y is the temperature in degrees Celsius. Okay, write a function f that models the temperature over time. And if you notice here, we're given the x-intercepts. Okay, so we're going to write this in intercept form. Okay, and once again, this is kind of the same concept that we did before in vertex form, where we have everything but the a, and then we find the a using the other point. All right. So if I write this in vertex form, I know that y equals a times, remember vertex form looks like this, and it's x minus the 4, and then x minus the 24. Okay, and notice the only other point that we're given on this line is this one right here. And guys, these just happen to be the y-intercepts. They won't always be the y-intercepts, okay? So we're given the 0, 9.6 is on this line. Okay, so that means 0 is the x value, and 9.6 is the y value. So we can plug 0 in for both x's and 9.6 in for y. Okay, so when we do that, I get 9.6 is a times 0 minus 4, 0 minus 24. Alright, so if I go by and keep simplifying it, I get 9.6 equals a times negative 4 times negative 24. 9.6 equals negative 24 times negative 24 is a positive 96. Divide by 96. I get 1/10 equals a. Okay, so after I get the 1/10, I can go back and I can plug it in right here. So my final function would be f of x equals 1/10 x minus 4, x minus 24. That is my final answer. Alright, so let's look at part B of this. Okay, so I'm just going to go ahead. We found the equation in part A, and that was 1/10 x minus 4, x minus 24. So I'm just going to write that down here to make our lives a lot easier. Alright, so in part B it says, what is the coldest temperature? Okay, so if I look at this graph, clearly my coldest temperature is down here somewhere. Okay, and notice that is my vertex. Okay, so what this question is asking is basically what is the vertex of this function? Okay, so remember on intercept form to find the vertex, you know the axis of symmetry is right in the middle of the two intercepts because of its symmetricity. I don't know if that's even a word, because it is symmetric. Okay, so to find the midpoint, you just find the average. So 4 plus 24 over 2 gives you 28 over 2, which gives you 14. Okay, now the x value of this is 14. Okay, but that doesn't tell you how low it goes. We need to find the y value at this point. So to find the y value, the x value at that point, so we can just plug the f in, or the x in. So f of 14 equals 1/10, 14 minus 4, 14 minus 24. Okay, and when we simplify this out, we get 1/10 times 10 times negative 10, which is 1/10 times negative 100, which is just negative 10. Okay, and to kind of be proper, it'd be negative 10 degrees Celsius. Alright, so if we look at C now, once again, I'm going to write the equation. I don't think we need it in this one, but we'll write it anyways just in case. We found that to be 1/10 x minus 4, x minus 24. All right, it says, what is the average rate of change in temperature over in which the interval in which the temperature is decreasing and the temperature is increasing? Okay, so first we need to figure out this average rate of change. Okay, so if you think back into middle school, this was the term used for slope. Okay, anytime you hear average rate of change, that just means the slope. That's a fancy way of saying slope. Okay, and remember, slope is y2 minus y1 over x2 minus x1. Okay, now we need to find out when is this decreasing. Okay, let's do the decreasing first. Okay, so we need to find the interval in which this is decreasing. Okay, so it's decreasing from here to here. Okay, so it's decreasing from 0, 9.6 to, and that's just the vertex, and we found that vertex. I forget what it was. It was 14, negative 10. Okay, so I'm going to write 14, negative 10. Okay, so now that I have my 2 points, I'm going to find my slope of those 2 points. So this is the x-coordinate of point 1, the y-coordinate of point 1, x-coordinate of point 2, y-coordinate of point 2. Okay, and then I'm going to plug it into my slope formula. M equals y2 minus y1, so negative 10 minus 9.6 over x2, which is 14, minus x1, which is 0. Okay, when I do that, I get m is equal to negative 1.4 degrees Celsius per hour is my units. Okay, so all I had to do is find my slope. All right, why don't you go ahead and try to find the slope on the increasing interval, and then we will go over it. All right, I'm going to go over the increasing interval now. So if you didn't pause it and do it, you may want to pause it now and try it before we go over this. So increasing. So the first thing you need to do is figure out where it's increasing from. So it's going from here to here. Okay, so it's increasing from our vertex, and our vertex was 14, negative 10, to it finally stops at, what is that point? 24, 0. Okay, so once again, I'm going to do the slope. So this is my x-coordinate of point 1, y-coordinate of point 1, x-coordinate of point 2, y-coordinate of point 2. And guys, just a reminder, if you flip these, like if you have this as x1, y1, x2, y2, that doesn't change. You'll still get the same thing, so that'd be fine too. All right, so to find my slope, it's y2 minus y1, so 0 minus a negative 10 would be a plus 10 over x2, which is 24, minus x1, which is 14, which is 10 over 10. So it increases 1 degree Celsius per hour. And those are my 2 answers. All right, guys, so what I want you to do is I want you to go back through example 2, kind of look it over, make sure you understand it. And then I want you to try to do this question right here, which is very, very similar to example 2, part A. We didn't go into the extra steps like B and C did, but we just want to find the formula. So I want you to try to do this on your own. If you get stuck, go back to example 2, and then we'll go over it, okay? So pause this right now and try it on your own. Okay, so what I did is I took my 2 intercepts, and then I plugged this in intercept form. So you should get y equals a times x plus 2 and then x minus 4. That just goes straight back from how to write intercept form. Okay, now I take my other point that's not one of the two x-intercepts, and I plug my x-coordinate in for x, my y-coordinate in for y. So I'd get 5 equals a, parentheses 2 plus 2, parentheses 2 minus 4. Okay, and so when I clean that up, I would solve for a and get negative 5/8. Okay, and then all I would do is plug this negative 5/8 back in for a to get this. This should be your final equation.